There we go. So we're going to talk about the Explore the Universe Observing Program. And start a little bit of history. So once upon a time, there was this guy named Leo Enright, who was an amazing amateur astronomer. And he wrote a beginner's guide for astronomers for the RASC, which was called the Beginner's Observing Guide, or the BOG, it was commonly referred to. You can see a copy of the 6th edition cover there. Went through multiple editions. And unfortunately, in 2009, he passed away. And this created a problem because the society wanted a beginner's book to continue, but in those days, until actually quite recently, the society didn't really have a professional publishing. They had a committee, and they didn't have contracts. So he passes away. Who has the rights for the copyright? And even worse, where are the manuscripts? Like, where's the word file, the PDF, or whatever? It was a mess. So when they sat down to try and figure out what to do, this lady came forward, another amazing astronomer, Brenda Shaw from the Toronto Center. And she offered to try to create a new beginner's guide. And she created a wonderful piece of work. But she was very, very courageous of her because she's a first-time author. It's the first time she's authored a book. And all because of the same problem with them being not really a professional publishing firm, they dropped her in the deep end and they didn't give her the editorial support that she needed. And so what happened was they published the book and then they showed it to some people for proofreading. And there was problems in the book. Imagine that. Like, one particular flaw involved one word in a sentence. And if that one word had been changed, it would have been correct. But that one word changed the whole meaning. So anyway, they all were running around going, what are we going to do now? We need an editor. And this guy, I think you recognize, came forward and said, yeah, I'll do that. So I teamed up with Dave Chapman, Dr. Dave Chapman, and Dr. Ray Bishop, and we came up with the 2nd edition, which you can see up there in the corner. And actually this morning at 8:30, I finished the editing on the 3rd edition, which is now going to go back to my colleagues with the PhDs, and they're going to make sure that everything is in place where it needs to be, and pretty soon you're going to see that. So the way this works, the wonderful thing about this program that Brenda created with her colleague Brenda Stewart, who did a lot of the drawings for the book, they call themselves the Royal Astronomical Brenda Society. It's a free download from the RASC website. You don't actually have to buy the Explore the Universe guide to do this. You can download the program. You don't need anything more complicated than binoculars, but the telescope is fine. Find 1/2 of 110 objects. You don't even have to be a member of the RASC to get this particular pin. And our center is a certification center, so we give you the pin. You don't have to write away to the observing committee or head office or anything like that. And as Dawn has already told you, the reason I'm teaching this today is because, well, I didn't write the book on the subject, but I did edit it. So they also recently came up with, you can see on the screen here, an Explore the Universe Observing Program workbook, which is also a free download. Print it yourself, and that's got all of the objects in there and all the notes pages that you need to do this if you want to do it that way. And there's the pin that you get when you complete this. So basically, you've got 24 possible constellations and bright stars as targets. You've got 32 lunar, 10 solar system, 24 deep sky, 20 double stars for a total of 110. You need half of each of those categories for a total of 55 to meet the requirements. There are some extra things you can throw in there. They're not necessary, but we'll get to that in a minute. The first thing I want to put out there for anybody who wants to get into this, or any kind of observing for that matter, is plan your observing session. Don't just go out there with a guide and go, let's see what I can find. Sit down, take a half an hour, and figure out what kind of a sky have you got up there and what are we going to go looking for. It'll save you an awful lot of time and effort. At the back of the Explore the Universe guide, you will see maps like this. This is one of them, seasonal maps that show you the sky. You could use these, but what I personally use is a free download called Stellarium, which is a planetarium program. I've spoken about this before in another presentation, but this is a really good program. You can search for the object, you could bring it up, and if you use the ocular control up there, you can even see what it's going to look like in an eyepiece. So anytime you see me up at the observatory, once we get that observatory open again, I guarantee if you come and see me and ask me for my list, I have a list there because I always plan before I go up there. Generally, I've got all the stuff I'm going to show the public. And then when everybody goes home, I get a list of stuff I'm going to look for. So it's definitely going to save you an awful lot of time and effort and possibly embarrassment, because there's nothing worse than saying, let's now look at the Andromeda Galaxy and press the button and have the thing point at your toes because it's below the horizon. So another thing that I want to bring up really quickly that I've run into with people that have come up to me at that observatory asking for help with the Explore the Universe is star catalogs. And it's not surprising because they're kind of a mess. So the way it works is this, history again. This guy named Bayer, back in 1603, published a catalog based solely on bright visual stars that could be seen with the unaided eye, because this is pre-telescope, just a few years before Galileo made his first observations of Jupiter or whatever, but it's pre-telescope. So this is unaided eye. What he did is he used the Greek alphabet. He chose the brightest star in a constellation, let's say Ursa Minor, the Little Dipper, and he would call it Alpha Ursae Minoris. And the abbreviation was the Greek letter alpha and UMI, okay? And then the second brightest star would be beta and so on. Okay, kind of makes sense. That way you've got a list that shows you everything in order of its brightness. That's kind of nice. But then if you go forward 125 years, oh, there's the Greek letters. I should mention that one of the things that was in the original edition of the Explore the Universe is they would say alpha, but they wouldn't give you to show you what the Greek letter looked like. And what you're going to see in a star chart is a Greek letter, not the word. So one of the things we did is every time it refers to a Greek letter, it's got both in the and in brackets the actual Greek letter. Makes it a lot easier to find things. So go ahead 125 years. Now you've got people using telescopes. They've been using them for about 100 years now, and they've very quickly realized there's a lot more stars out there than you can see with the unaided eye. So now we need some system to label those as well, because we've run out of Greek letters. So FLAMSTEED said, no problem. We're going to start on one side, the west side of the constellation. We're going to move over to the east, and every single star gets a number. So they're in sequence from west to east. But then what happens is people go, yeah, but my grandfather used that old system, and that's the way we've always done it. And so what they did is they compromised. So now, when you look at the star chart, the brightest stars all have that Bayer classification, but then all the rest have FLAMSTEED. So you're going to see a whole bunch of Greek letters and numbers. So you've got a mixed system where one half of the system is showing you stars in order of brightness and the other in order that they appear from one side to the other. And then on top of that, people said, yeah, but hundreds of years before that, the Arabs recovered all that information that Plato put out there and republished it as the Almagest and came up with 1,024 names of stars in the sky. And then some not very competent 13th century translator took stuff from Arabic and into sort of English, corrupted a whole bunch of names, and those are the names that we have been using for hundreds of years for the stars. So they're on the star chart too. So they're all in the Explore the Universe, all three sets. So you should be able to find things no matter which one of these you end up encountering. And we'll come back to this later. So what's actually in there that you have to look for? Lunar phases. You need 4 of 8 lunar phases that are listed here. You can also list orbital motion by going out a few days in succession and looking at the moon against background stars. But here's something to keep in mind. You don't have to do lunar observing at night, because in the early days of the cycle, the moon's up there in the evening sky before it gets dark. And in the late parts of the cycle, the moon's in the sky after the sun has risen. And I was working on the Isabel Williamson lunar observing program, and I was doing it in broad daylight quite nicely because it's a clear sky and there is the moon and it's a bright object. So if you're looking for observing the dew during the day, you might want to try the moon because it's up there and it's easy to see. Well, one of the things you're going to run into if you're new at this is if you're using a telescope like my Schmidt-Cassegrain, it's going to reverse the image like that. And that can be kind of awkward if you're using a star chart or a lunar map, I should say. But there is a way around that. You can get a chart which on this side has got the moon as you see it with the naked eye, but then if you turn it around, that's what it looks like in your telescope. You could also get an atlas. This is my Hatfield SCP Lunar Atlas. It's got all of the maps, all of the photographs of the moon, the various craters, all handily reversed to make it easy to sort out. So you need to find 6 of 12 lunar basins, and here they are, and here's the best day to view them, depending on the phase of the moon. And I kind of like this diagram here because what this clever person did is he took an LRO image and he actually made the mare, which are actually not, oceans at all, made them look like oceans to make them stand out. Because Galileo, he called them mare or oceanus, possibly thinking he was looking at oceans. We're not entirely sure whether it was just a handy thing to do or whether he really believed it was water. But here you see, this is the way you'd see it with the naked eye or binoculars. You can see there's the Sea of Serenity, Tranquility, and Fertility going down on an angle with the Sea of Nectar and the Sea of Crises up there above it, very obvious circular one. And then Oceanus Procellarum takes up most of the other side of the moon. Mare Frigoris up top, Mare Imbrium, Mare Nubium. Those are quite easy to find. You also need to go after 6 impact craters. And you can see again on this chart, there are certain days where they are best viewed because the terminator is near them and you can see them in better detail at that phase in the cycle. So let's go through them quickly. You've got Petavius. These are all big craters. This is 177 kilometers across. It's 3.4 kilometers deep. And it's got a massive complex central peak and a floor uplift. It's got all kinds of rifts that you can see there. It's got terraced walls, all kinds of interesting things to look at. Kilomedes, which is 126 kilometers across, 2.7 kilometers deep. Fairly eroded. You can see all kinds of other craters superimposed over it. Posidonius, which is 95 kilometers across, 2.3 kilometers deep. It was flooded with lava. You can see all kinds of fractures and rifts and things from the activity that's been going on in there. Theophilus, 100 kilometers across, 3.2 kilometers deep. This is at the edge of Mare Nectaris, and it's part of a trio, which you can actually see they're going up to the right with Cyrillus and Caterina. They're all about the same diameter. Aristoteles, very prominent terraced walls, 87 kilometers across, 3.3 kilometers deep. Ptolemaeus, look at all that cratering in there. 154 kilometers across, it's one of the larger ones, 2.4 kilometers deep. Easy to see with binoculars. Plato, 101 kilometers, 1.4 kilometers deep. This is a very dark floor. It's right at the edge of Mare Imbrium and south of Mare Frigoris. It's quite a good target. Tycho, 86 kilometers, central peaks, wall terraces. It's one of the youngest craters on the moon. There's all kinds of bright rays that go across the surface from ejecta that you can see. Clavius, this one's pretty eroded, lots of impacts wearing it down. This is one of the larger ones, 231 kilometers across. Copernicus, 93 kilometers, 3.8 kilometers deep. Got some really good central peaks, all kinds of terraced walls, prominent ejecta blanket around it. Gassendi, all kinds of fractured floor peaks and things down there. And finally, Grimaldi. I think this is the most eroded of a whole bunch here. You can see there's a lot of impact craters that have worn it down. Now, If you're really interested in geology, the moon is really a good place to go because there's lots of geology. I'm a physics guy. Give me a planetary nebula. But even though I'm not really into geology, there's all kinds of really interesting stuff to see there. Okay, so solar system, you need 5 of 10 objects. And there are all the planets there. We'll get to that in a minute, but there's also orbital motion. Like the moon, you can plot the motion of a planet across the sky. So yeah, Mars isn't too exciting right now, but you can go out there and look at it at different periods and see how it's moved across the sky in relation to the stars. Artificial satellites and meteors, you can observe at least 3 artificial satellites. That's including spacecraft in the ISS, and 3 meteors. And that doesn't have to be meteors in a meteor shower, it could be sporadic. So you know what, just about every single time I've ever been at the observatory for a few hours, I've seen at least 1. So that's pretty easy to pick up. And then sunspots. And of course you need proper observing equipment, but we have, as a club, got a hydrogen alpha Coronado scope that you can borrow to do that if you want. But for this particular exercise, all you need is like eclipse glasses, because we're not looking for anything more complicated than sunspots. Now, I'm not going to say much more about the planets because it's already been observed by somebody during the previous discussion. First of all, Bruce Fryer usually covers these in his Skies This Month presentation, so he does an excellent job. I'm not going to upstage him there, but at this particular time, all of them except Mars are all jammed in close to the sun, where you're not going to be able to see them. So Mars, if you're wondering, is up right beside the head of Taurus, that triangular form of stars with all the Baron in the corner, the Hyades cluster. Now, if you're trying to figure out about those satellites or the ISS or minor planets or all kinds of other things you can observe in the sky, one really useful website is Heavens Above. It was created by a German astronomer. And the link is in the resource page on their website. I went there today and made sure that it's in there. It's quite easy to use. You can use this to figure out where the iridium flares happen. It'll give you a map. It'll show you the location and the timing. It's a really, really good site. It's even got some fancy things like this. This is like just a picture, but if you were looking this at the site, the Earth is turning underneath the International Station and showing you exactly what the crew is seeing or where the thing is at that particular moment in time. So it's a very useful site if you're looking for some of these targets you want to look at. Another one, and again, the link is on our website on the resource page, is spaceweather.com. And if you're trying to figure out if there's any sunspots and where they are, there's the sunspot diagram on the left there. You can click that and it will come up to a big screen so you can see it more clearly. It's got information on what's going on in the sun. You can see there's a magnetic storm watch this morning for a G1 class storm, which could possibly create some aurora. And if you go lower down on the page, you will see this, which will show you exactly where the aurora is forecast to be. And obviously it's not going to get anywhere near us in this particular one, but it's a very, very useful tool. I look at this thing every day. It's a thing. So there's some optional observations. You can go after a solar or lunar eclipse. We'll get to that in a second. You can go after a conjunction of planets. This is when 2 objects are on the same line of right ascension, like celestial longitude, if you will, which is a fancy way of saying they're close to each other. If they get really close, you can have an opposition where one goes in front of the other. You can find those oppositions and conjunctions in your observer's handbook. Meteor showers, again, you can find that in the handbook, but I today updated the meteor shower page of our website, so it's got all of this year's meteor showers in there, when their peak is, what their zenithal hourly rate is, so you can get an idea of how many per hour you're going to see, and also what percentage of moon you're going to get. I'm going to get back to that in a second. We've already talked about aurora. Comets, again, you can find a list in the observer's handbook, and you can figure out, what comets are in the sky. some of them become very visible, and you can get a pretty spectacular view, with the naked eye, but most often it's a little fuzzy blob in the sky you got to chase with your telescope. But we can get you the location. Zodiacal light is another thing that you can go after, although as Richard was mentioning earlier, it's not easy to do up here. It's something that happens after dusk in the western sky in February and March, in the pre-dawn sky in September and October. And what it is the light after the sun is set, reflecting off interstellar dust. And it used to be thought that it was from comets and that sort of stuff. But this month, I don't know whether you noticed, on the NASA site, they announced that the scientists who had sent the probe that is currently orbiting Jupiter, on the way, it basically went through a region of space where it was sandblasted. There was all kinds of particles hitting this thing. And they were able, because of the cameras and the instruments on board, to track where that stuff was coming from. It's sand from Mars. It's the dust storms from Mars. Some of that escapes the surface of the planet and ends up creating this dust plane out there. So now we're pretty sure, scientists are pretty sure, that that zodiacal light is very often light reflecting off of that Mars dust. Fun stuff. You can also try to locate a dwarf or minor planet, and again, there are charts and maps in the Observer's Handbook where you can locate those. But these are all optional. These are, fun to do things if you are looking for something to do, but you don't have to necessarily go after them. As far as meteor shower is concerned, just quickly mention that the ones that are coming up right up to the Perseids, which is going to normally happen during the events that we hold in Porpoise Bay Provincial Park when we were doing astronomy in the park back when we were pre-COVID. Here they are, all listed here, and you'll see that you've got the Aquarids, you've got both the Eta Aquarids and the Delta Aquarids and the Perseids. And the nice thing about all of these is the moon is hardly there. It's like 20% or less. So these are all going to be pretty good. If there's anything to be seen, you're going to see them. There's another one that happens in April, but the moon's about 80% there, so I didn't include it here. But these are really good ones if you're looking for a good possibility of catching a meteor, 3 meteors for your list. These are good places to try. And there's the April one included on the list. That one's got a lot of moon. For eclipses, there's going to be a total lunar eclipse on May the 26th. But where we are here, you're only going to see the beginning. The moon will set before the full eclipse occurs. So you'll get a glimpse at it. On the 10th of June, there's going to be an annual solar eclipse, which you see in the picture here, where the moon does not quite completely cover the surface of the sun because it's out at apogee rather than perigee, where it's in close, where it would cover the whole sun. So it's not a total, it's an annular. But to see it, you're going to have to be in way northern Ontario, Thunder Bay, in the Arctic, way up there. There's a lot of RASC members talking about this, most specifically members that are in that part of the world. So, there's definitely people interested in going up and trying to view this, but that's all we've got going in Canada this year. There will be a partial lunar eclipse on November the 19th, which will be visible all over North America. And on December the 4th, there will be a total solar eclipse, but the only place you can view it from is the Antarctic. So that's not terribly helpful. Not a lot of choices there. Okay. Another thing that's in the Explore the Universe Observing program is constellations and bright stars. And you need 12 of the 24 on this list. Now, if you go down that list of constellations, you're going to see that some of them are what people refer to as signs of the zodiac. There are 12 constellations that are spread out along the path that the sun travels across the sky, the ecliptic. They're called the zodiac. Some of them are on this list, not all of them. And a lot of them on there aren't part of that at all. So why did they choose these? Because they have the brightest stars. Why is that important? Well, if you're starting out in astronomy, I always recommend that you go out as the sun's going down. That's when you start doing your star alignments. That's when you see these stars. These are going to be the first stars that you're going to see in the sky above your head. And if you've got a telescope like I've got there, which is a go-to, one of the first things it's going to do is it's going to ask you to do a star alignment. And the stars that are going to be on that list are these stars right here. So that's why you want to know at least some of these, because that's going to help you to get set up and get things going. So the ones that we're going to worry about tonight are the ones that are in the spring sky list. We'll get to the others when I come back later in the year and talk about the other seasons, but here they are. So you've got, here's a piece of sky above the Sea Shelf Observatory, and there is Ursa Major and the Big Dipper, and there's two of them there, Duvet and Merak. Below the Big Dipper, you've got Leo, and you've got Regulus and Denebola there, which are two of the other stars. To the left, you've got Virgo, there's Spica. To the left of that, you've got Libra with Zubin el-Shamali and Zubin el-Ganubi. And just above Virgo there, you've got that kite shape, that very bright star down at the bottom, Arcturus. And of course, up there, you've got the Little Dipper, which has got Polaris, but it's also got Kochab. So those are all the bright stars that they would like you to look for in this season. And we'll be coming back with more constellations and bright stars in the summer. We also have deep sky objects. And you need 12 of 24 of these. And again, they're divided into seasons. So let's just look to see what's on that list. We got 13 open clusters. We got 4 globular clusters. We got 4 emission nebula. We got 2 asterisms and 1 galaxy. That's what we got to work with. So this season, we're looking at these 3, the Beehive, the Coma cluster, and M5. So the Beehive, they're down in the bottom right corner. You can see the top of Orion. There's the Milky Way going by just above Orion, and standing on top of it there is Gemini, the twins, Castor and Pollux. Just to the left of those, you see that group of stars, which has that little line in the middle and 2 triangles off at either end. That's Cancer. And right there in the middle, just to one side of that center line, that's where the Beehive cluster is. And it is an open cluster. It's a magnitude 3.1. Contains red giants and white dwarfs along with main sequence stars, about 577 light years away. It's about 600 million years old. It's got a bright central core with a diameter of about 7 parsecs. It's about 22.8 light years. Pretty easy object to find in the sky. The next one, there's Leo, which we mentioned is just down below the Big Dipper. You can see the handle of the Big Dipper right in the top there, running through the title there. And just down here below them, you see this triangular structure. And that yellow circle is surrounding MELOTTE 111, the Coma cluster. It's quite a large cluster. Now, it's about 280 light years away, and it's got about 40 brighter stars between magnitudes 5 and 10. And they make, part of the cluster is actually that V shape that you saw with the 2 lines there defining the constellation. It used to represent the tail of the constellation Leo, but then Ptolemy, around 240 BC, renamed this Coma Berenices for the Egyptian queen's legendary sacrifice of her hair. So it got separated at that point. M5, there's Virgo and Libra that we mentioned a moment ago. There up at the top, you see Arcturus, which is that bright star in that kite-shaped constellation Boötes. And there, where the arrow is, that's M5. Quite easy to spot. It's a globular cluster. It's a pretty impressive one. I show this to people at the observatory all the time. Magnitude 5.7, so it's right at the edge of unaided eye. About 2,450 light years away, about 80 light years across, about 13 billion years old. Beautiful jewel box in the sky. We will come back with more deep sky objects in the summer. We're just going to leave you with those threes right now. Now, double and multiple stars. You need 10 of the 20 on the list. And you see this again, it's actually broken into 3 pieces. The spring list is quite a large one. And here's where you're going to run into that fire, FLAMSTEED, Arab name thing, okay? So you'll notice on this list, we've got all 3. We've got everything there, so no matter what star chart you're using, you're going to be able to find one of those things on there. Let's take a look. There is the spring list right there. Let's go through it. So here's Leo. We showed you that a moment ago down there below the Big Dipper, and that star right there at the back end of Leo is Adhafira, and it looks like this when you're looking at it. The next one is over in that MELOTTE 111 cluster that we just were showing you there. There's COMA BERENICES, okay? That's the cluster right there. And in that cluster, one of those stars, that one right there, that is 17 COMA BERENICES. That's one of the targets. Another one is 32 and 33, which is a little bit lower down, right about there, like that. Canis MENETICI is in between the handle of the Big Dipper, which you see again right behind the title there. You can see the 2 end stars of the handle, and COMA BERENICE that we're just looking at with the MELOTTE 111 cluster. And just below those 2 fairly bright stars that form this minor constellation, you'll find this pair, 15 and 17 Canis MENETICI. If you go up to Big Dipper, this is one of my favorites. It's one of the easiest ones to find on the list. Right there with the handle, right there, that's Mizar and Alcor. And they're very distinct. 81 light years away and about a light year apart. And they are quite an easy target to find. Libra, remember we had Zubin El Shanali and Zubin El Ganubi. Well, Zubin El Ganubi there, right there in that corner, is a pretty impressive star pair with one slightly brighter, larger, and bluer than the other one. And going up to that kite-shaped constellation, Boötes, with that very bright star Arcturus, if you go just above the end there, Alcalarops, that is a double star. If you go over between the main body of Hercules and that minor constellation forms that semicircle, Corona Borealis, you'll find new 1 and 2 Corona Borealis. Looks like that. And then if you go over towards Draco, which is that long line of stars that winds around the Little Dipper, between Little Dipper and Hercules, and right there, you'll find 16 and 17 Draconis. So that's another one of your targets. And we'll be back with more double stars when I do my summer presentation. So you got targets. So some people have already started, and actually 2 people have checked in since I sent the email out. I would like everybody who's doing this to check in so we know roughly where you are. And if you need help with stuff, we can give you some suggestions or we can help you along with this. And we like to plot people's progress on the website. I haven't started doing it yet because I know there's more than 2 and only 2 have checked in, like I said. But we can help you make your way through the rest of this. Now, there are other observing programs. And let's go through them really quickly. So there's Explore the Moon. It's really simple. There's only 40 things you have to find with binoculars, 94 if you're going to do a telescope. Quite easy to do. There's the Isabel Williamson Lunar Observing Program. This is a lot of work. This is complex. It was created in 2006 as a certificate program for intermediate to advanced observers. You need a slightly larger telescope for this. But this is a really good program. And like I was saying earlier, if you're really interested in geology, this is a great observing program to do. I did it. I've just completed it actually. And like I said, it was a lot of work. It spread out over about a year and a half, but it was a good project. There's the Messier pin that you can get. This basically is going through and nailing all 110 Messier objects, which you can do in one day on certain days of the year. If you're absolutely mad and decide to stay up all night, I wouldn't do it that way. But you can, you know, in the course of a year, quite easily put together the whole list and get yourself a pin. Finest NGC is a good program. It's got 110 objects too, but it's all new general catalog and IC index catalog objects, and I've done it. It's a good program, and it's sort of like the Caldwell catalog, which isn't an observing program for the RASC at the moment, but Sir Patrick Moore of UK astronomy fame, he came up with a list that was complementary to the Messier catalog, but didn't overlap with it, of objects that you could find that were equally prominent. Some of them were in the southern hemisphere, so that's a good one to do. It's also the Deep Sky Challenge, which was put together by Alan Dyer and Alistair Ling. There's no overlap with that earlier NGC list. It's more challenging. I've got just all but 3 I've got in this one. I've been working this one. I've been working this one too, Deep Sky Challenge. It's only got 45 objects, but there are some really weird and wonderful things in this one. Again, I haven't got them all, but I'm getting pretty close. So there's all kinds of challenges that you can take up, all kinds of stuff that you can track down. And Deep Sky Gems is another one. It was created in 2008 it was based on David Levy's Deep Sky Objects book. Many objects are NGC and IC, but there are some unique objects in this one too. So lots of stuff. 154 objects in this one. And there's some pretty interesting things to track down. You can even do solar observing. Somebody wrote a book about that. So that's it. That's the deal. That's what I would like to see people take on, because it's a really good way to introduce yourself to all the different aspects of observing and get started on things. And then once you've got this behind you, you can go on and master any of those other things without a whole lot of help from us, because you'll have picked up all of the basics that you require. So, questions?
Yes, Charles, all those slides that you showed, can we see them on the RASC website?
I will turn that into a PDF and I will put that on the website. No problem. We also we are recording this right now. And so I'll be making this into a video to go on the YouTube site as well. But yeah, no problem. And when I do the other presentations, and I'll make PDFs for those as well.
You mentioned that the guides were downloadable as a PDF. Where do you do that? Because if I go to the...
If you go to the RASC website, and one of the tabs at the top of the page is Observing Programs, click on that. And when you get that page, it has all of the different programs I just mentioned. Click on Explore the Universe. And at the bottom of that page, there's all of the different downloads that you can do. You can download the basic program list. You can download the workbook. You know, there's all kinds of stuff. You have to buy the Explore the Universe guide, but it's not expensive. It's fairly cheap. And
okay,
I understand they've been giving it out to recent new members of this society because it is so cheap to produce. So yeah. Yeah, you can download everything you need for free from the site, no problem. And if you have a problem with it, get a hold of me. I have downloaded them all myself. I'll just email it to you, no problem.
All right, thanks you.
Any other questions? Okay, thank you for your attention. And if you can think of something later that you'd like me to answer for you, don't hesitate.
I was going to ask a quick question, Charles.
Sure.
So this is where you actually work on your own, or can you work in groups of, I mean, with COVID, I mean, be socially distant, can you still, would you recommend pairs or on your own, or how?
You know, back in the day when we were pre-pandemic, it was pretty common for people to come up to the observatory when we had an open session going on there, and there were multiple people with telescopes out there. And when people would come to me and say, "Okay, what targets can I work on?" and you'd help them find stuff. You know, it wouldn't be difficult if some people wanted to get together at the observatory and have spacing, but one of us, you know, could point out things in the sky, and you could have your own telescope or binoculars and spot these things. We could work out something like that, but I mean, basically we can't share eyepieces. There was actually an interesting discussion on the RASC Rascals page a few days ago with somebody from the Education Committee, and what they were talking about was using one of these printers to create eyepiece covers, replaceable eyepiece covers. You get a whole bunch of pre-sterilized covers, and you could switch them off for give each person their own cover, and they could use that to use the eyepiece for their observing. So I've been waiting for them to get back with the information on where the details are on how to do to print one of those things, but I'll let you know when they get back to me.
Interesting idea.
It is, but I'm not sure whether they were talking about 2-inch or 1/4-inch eyepieces. I suppose you could do either.
The other possibility for a group gathering, though, is that you use a green laser pointer. I know we can't do that at the airport, but we could do that at other sites.
Oh yeah,
And you could direct people to say, this is where you need to look.
Thank you for that, because I have a really good green laser pointer, and if we were to meet somewhere other than the airport, we could definitely use it. We are, as a society, in the process of setting up this green laser certification, so we could use it there. We haven't, as a center, made the effort to put in the application yet, but you can get an application that will allow you to use one of these things with the conditions that are specified to point things out.
Even so close to the hospital?
Yes. But to do it, you would basically need a person with a laser pointer and an observer.
Yeah.
And their job is to keep an eye out for watching for aircraft.
Oh my God.
They see an aircraft and they give the person with a pointer a poke and say, yeah, don't point it over there. You know, that's the deal. I've seen them using it that way at the Prince George Observatory, and they got a pretty powerful laser pointer there, but they always have an observer to make sure that, I mean, the person using it is focusing on what they're pointing it at in the sky, and they're talking to people about what they're pointing at, and they're not looking around the sky to see if something's about to fly into that piece of sky. That's why you need the observer, to make sure that you've got that covered. But as long as you've got that, that's the principal concern is blinding a pilot, you know. And I understand that, having been a pilot, so yeah. But we could do that. You know, we could meet somewhere and have somebody point out objects in the sky with a laser pointer, no problem.
Yes, I'll get my name on there too, Charles. I'll be starting completely over. It's been too long since I've started it, so I'll start brand new.
Okay. You know, I mean, a few years ago, just talking about observing programs, I was running the observatory, and I noticed one of the people who is at the meeting tonight standing out on the deck looking up at the sky and using binoculars, and there was a moon up that night, and after a while, it was a break in the action. I went out and said, hey, what's going on? He goes, you know what, all these years I've been an astronomer, I've never looked at the moon, and there's actually a lot to see up there. And I mean, that was what got me thinking about, hey, maybe I should try that. And you know, it was interesting. You know, there's a lot of stuff I didn't realize that's up there on the moon in that Isabel Williamson observing program. There's a place, Hell's on the moon. Did you know that? There's a crater called Hell. It's named for a priest by the name of Maximilian Hell. What a name for a priest. But yeah, if you ever wanted to tell somebody to go to hell, you could actually give them the actual location on a map, because it's on the moon.
ask a question?
Yes.
I've been struggling to do this for a while to find the different things. But if someone can come with a pointer, isn't that cheating? I mean, it sounds great. Please all come over and point to the things I'm trying to find.
Yeah, yeah, good point.
You know, I mean, I don't think that it is, because basically it's easier to show you patterns in the sky. You know, if I was to take a laser pointer and say, okay, there is Leo, now find this. Take these two stars and draw a line across. You're the one that's actually taking the binoculars, the telescope, and following down that line to see the object. You're not going to see it just because I'm pointing at it.
But you're saying here is Leo. I spent half my time looking for Leo. I was happy to find Orion and find the Castor and Pollux.
Well, you know, and I've said this in other presentations that I've done involving star hopping and so on, you don't need to learn the 88 constellations. You really, really do not. All you need is like 3 or 4 asterisms, which are small groups of bright stars, like Orion, like the Big Dipper, you know, like the Keystone of Hercules, like the Summer Triangle. And then from those, that you can point out just about everything else you want in the sky. I mean, you know, after a while, you'll get to learn all these different things, because you spend that much time, you know, cruising around the sky like that. You can't help but pick up, you know, little bits and pieces all the way along the path. That's the way I did this. But
Thanks.
you know, you don't have to memorize all of these. You really don't. But I think the hardest objects to find on this Explore the Universe program are the double stars, because you need to, you know, figure out the star lines that point at these things. But some of them, like the one in the handle of the Big Dipper, are quite easy to find. And some of them are parts of fairly prominent constellations like Libra, like Leo, or whatever. So you can generally work your way through